Let's get started. Okay, good morning, everybody. Welcome to Developer, of course, awesome community event. Happy to be here and happy to kick the day off. So let's get started. First, of course, some housekeeping. We need to all abide to our code of conduct, of course. We are all people here, so please be nice and understanding to each other. You never know what's happening in somebody's head. So be open and communicative and be very aware of that. If you have something that you spot that you think that is violating the code of conduct, please report that issue. That is our job as a community as well. And somebody will look into that and see if we need to enforce things. We are an open source or an open community for developer, of course. And since we don't have any cost to cover right now, we still have sponsors. We donate all the proceeds over to the National Museum of Computing, who do such great work for our industry. So be aware of that. It's very nice that the conference does that. Thanks to our sponsors, of course, Black Marble, Sage, Landmark, and NDC London, who are very much helping us out to even do this. I see some things in Discord that my slides aren't advancing. I'm already at the sponsor page. If you don't see my slide switching, then we have a problem. I'm hoping that Andy can fix things then.
I'm seeing it advance both as the producer and as the attendee. So.
Okay. Steve says it has. Okay, then I'll just continue and hopefully you can follow along then. Of course, this is a community thing, so please make it social, engage with all the speakers. It will be very helpful to have some feedback on Twitter as well. Use these hashtags and tweet them out to Developer Day, then they will pick it up as well. All right, and now let's dive into GitHub Actions. This is the reason why you're here, of course. My name is Rob. I'm a DevOps consultant in the Netherlands, working for Xperia, doing some large-scale stuff at our customers. And every once in a while, I find something online, or don't find something online, and then it, of course, always begs the question: am I really the first one to encounter this? And from that, I usually blog about it on DevOpsJournal.io, so you can follow along with the things that I've learned so far. I'm very active there, so if you have any questions, reach out to me there. You can find my LinkedIn, my Twitter, my YouTube channels there as well. I'm always happy to dive deeper into those weird things that we come up into. And that is happening with GitHub Actions as well. Because initially, I started using Actions when the beta came out in 2019. And then the guidance was always very straightforward, do this in a secure way, but somehow along the line of this product becoming of age, that message is being watered down. So I'm very happy that you are here to learn something more about the security aspects of using GitHub Actions, because we all want to try to be the person that got our company in the news with the latest breach or the latest information leak, for example. So I'm here to show you what you need to be aware of and what you can look at and improve, of course. But before we dive into that, I'm assuming that you at least know a little bit about actions, but still I want to make sure that we're on the same page because we need to have the same vocabulary. It's not just about actions, it's also about workflows. The workflows are the text-based files that are stored inside your repository, and they will be started on an execution environment. We call that a runner, and they will do the work for you. And they then execute one or more actions for you. So the product name is GitHub Actions. The workflow files is the things that you configure, and then the steps in the workflow file are the actual actions. We have lots of things that can trigger a workflow file. There are over 30 events that can trigger a workflow file. Somebody creates an issue in your repository or a comment on a pull request, or somebody creates a release. Those are all examples of events that can trigger a workflow. Then a runner is scheduled or placed asking for work, and then we'll pick up the work for you, and it will start executing your workflow files then. As I said, the actions then are steps in your workflows. So that means that they do the actual work, and it can be as simple as running a standard shell script. So you can do things on the runner itself. But of course, you can build on top of that. We have libraries for it as well, and that means that you can create your own action that does something specific for your needs. You can also say, I don't want to reinvent the wheel. There's a marketplace for actions as well, and you can use an existing one from there as well. We all currently have over 10,500 actions available on the marketplace. And this is the public marketplace. You need to have a public repository so you can publish your action to the marketplace. So the community is building this up massively. It seems like this number is going up with at least 1,000 each and every month. So it's picking it up. And if you see something that you find missing and you cannot find it on the marketplace, then you can create your own and share that as well. I'm doing that by myself as well. And it's very helpful to see what you learn from that as well. So with that out of the way, let's dive into the security aspects of using actions. I'll go over all these topics. Let's start with repository security first, what you need to be aware of what is happening inside your repository when you use actions. And that is divided in 3 different topics for now. Who has access to your code? We'll dive into workflow secrets, and you need to think about your own code as well. For the access to your code, you can set those levels at the normal 3 levels that GitHub always has. You can set them at the lowest level for a specific repository. And you can also do that for an entire organization where you can give somebody access to all the repositories in the organization. And a similar thing happens on enterprise, where you can give somebody access to 1 or more organizations in your enterprise. For those access levels, we have different permission levels. It starts with you have no access, you cannot log in, you can't see anything. You can get read-only access, and any authenticated GitHub user that goes to github.com has read-only access to all the public repositories. This is the way that the open source community works, of course. Triage gives you a little bit more on top of read-only access. You can manage issues, you can triage pull requests. Write access had a little bit more information that they can do. They can actually create branches and push commits into the repository. Then we have the maintain level. A maintainer can do more than just write. They can, for example, edit a repository description. They can enable a wiki or discussion for having a discussion forum there. But they don't have access to anything sensitive, like, for example, viewing the scanning alerts that come up in the repository. They can't remove things like delete or transfer the repository, or delete a package or a release. And then we have admin that just has blanket full access to anything in the repository that they have admin access to. If you want to know what the user has access to, you can go to the user. I'm using here my Global Devs Bootcamp organization that I'm an owner of. You can go to the people tab if you have those rights. And you can go to the user, find them, and then see what they have access to. You can see that I, as a user, have owner access to the entire repository. So that means that I have access to all the repositories in here. You can see that I have access to 81 repositories and I'm part of 2 teams. And per repository, you can even see that I have specific access on a repository as well. So you can easily find out what access somebody has. And that means that they can do things with your code in the repository and the things around your code as well. Also wanted to quickly touch on workflow secrets because we can use them inside of our workflow files. And we do that by injecting them into either an action or an environment variable. And you use them by using the $accolade setup, saying in this case, we are tagging secrets here, and I'm injecting a publish profile secret that is named that way. In this case, it actually contains an Azure publish profile as well. By doing this, you give the workflow that is being executed access to that secret, and it can do things with it. The nice thing of workflow secrets in GitHub is that they're actually secret. They're encrypted client-side before being sent over to GitHub. The UI does that for you. There's a public key that can be used to sign the data. And if you want to use the REST API, then you need to sign it yourself. And that means that they're actual secrets. There's no way to decrypt them from you as a user perspective. You cannot get the private key, for example. And the secrets are metadata around your repository. That means that when somebody forks your public repository over, they don't get access to your secrets. So that's very good to be aware of. But for forks, that of course goes for everything. They fork over your repository, but they only get the code and the history there. They don't get access to your issues, for example, or the pull request in there. So that goes for secrets as well. Looking to who has access to your secrets, it is very specific because you can only create secrets, for example, at the repository level, when you have admin access to that repository. And then updating and delete them has the same access rights. So you as an admin can set those secrets and tell everybody, hey, these are the secrets that are available to you. And then anybody with lesser rights can only use them inside of workflows by executing them. For creating them at the organization level, you need to have administrative access to the entire organization. The nice thing of setting them on the organization is that you only have to set them once, and then you can use an access policy to give everybody access to those secrets. You can say these 5 specific repositories for that team can get those secrets, and now I have one single point of updating and maintaining the secrets in there, and that's very helpful, of course. As I said, they are encrypted, but only until the workflow file starts executing them. The runner executes your workflow file, and they get the secrets injected either as an environment variable or as direct input into your shell commands. And that means that the action can do anything with it. GitHub tries to redact them in the logs, and they use a regular expression for that. And that means that's exactly the reason why I say GitHub tries to redact them, because trying to redact strings with regular expressions can be very hard, especially when you use structured data like XML, YAML, or JSON inside of the secret files. And some cloud systems have that as a secret, and they say, hey, here's a JSON setup that has all the keys that we need to implement them. Well, that is very hard to redact then inside of the log. So if you use that, remove all the new lines or the line ending in there, the spaces in there to make it a plain string. That should still work with wherever you're sending that JSON in. But that helps you and helps GitHub redact that secret data. Because, as I said, the action can do anything with them. They get them as plain text. So they might pull them off to a third-party API endpoint, for example. Or they do weird things, or they mess things up, and they pull them out into the action logs. And that's why I say be very aware of what you do with your secrets, because anybody who has access to the action logs can read those secrets if they happen to occur inside of your logs. And as I said, anybody with who has been authenticated against GitHub.com can see even the action logs in read-only mode of all the public repositories. So it might be a very large security leak that you encounter there. I've got an example here on the lower left-hand side of echoing a secret out into the log. And the first one is, of course, straightforward. I'm echoing my secret.demo log in there. And the second one, I'm doing something sneaky. I'm adding a space after each character inside of the secret. And of course, guess what happens? On line 6, you see the result of the first echo that is being redacted. And the second one, all of a sudden, my secret is visible in plain text. So be very aware of when you give an action your secret, because it might do things with them. So in my opinion, it's best to treat them as public and then use an external mechanism like Azure Key Vault. And we have OpenID Connect now that can connect with Azure, AWS, and I think GCP as well, and to securely do your deployments, for example, into your cloud environment. If you want to know more, let me know, then I'll share some information about that as well through the chat, for example. Okay, now let's dive into your own code inside of the repository, because your own code is stored in the repository. And with your own code, I mean anything. Your workflow files might be a potential attack vector. The shell script that you use to build or deploy your application is an attack vector. Even your own code might have a vulnerability where when you build it, it might trigger something, and then that might be misused inside of your workflow file. Also, with all the dependencies that we use, hopefully you're still not building up your own OAuth authentication, for example, or your own encryption methods. You use third-party packages for that. Well, guess what? They can have vulnerabilities as well. Similar for all the containers and all the layers that we use in there, we need to properly secure those things. So as a best practice, start with static code analysis on your own code, and then look into software composition analysis. Check all your third-party dependencies. Depending on what research you follow, at least 70% of your code is in yours. And I've got a colleague that even states that 99% of your code is in yours. Scan that code as well. There's a known vulnerability database available, multiple even. GitHub has one as well. You can scan your own code with static code analysis, dependable, to figure out what is happening in your code, and then verify the list of packages that you use against the known vulnerability database. And from that, of course, always try to keep your dependencies up to date. There might be security fixes, there might be extra functionality coming in, but at least pull in the security fixes. That already saves you a lot of headache. And we all know things like bit rot happen. We have for Global Devs Bootcamp an application that we haven't touched for a year. We're now building it up for the next episode in 2022. And we ran that through Dependable, and we found hundreds of vulnerabilities already. just by not touching that code in a year. So even if our code doesn't move, the attackers do move, and we find vulnerabilities in those packages. So scan your dependencies. If you want to know what happens inside of your own code, we've got two ways. For your own code, you can go to the Git commit history. Everything is there. You can find all the changes that are there. But what I wanted to show you was the audit log, because everything around your code, like issues, enabling features, is inside of the audit log. You can find that at the organization level. Here I've got my Global DevOps Bootcamp organization. You can go to settings and then to the audit log, and you find everything in there. People creating personal access tokens, adding SSH keys, adding or deleting secrets is in there. Even enabling a feature like a wiki on a repo is stored inside of the audit log. Be aware that the audit log only has the last 90 days of data for you. So if you want to have more information and store that longer for auditing purposes, of course, you need to stream that data out of the system into your own system. Go to your own account. This is my own GitHub handle. You can go to your user profile, go to settings, and in the security log, you find the same information for what is happening in there. So very good that you are aware of where that is happening. That concludes the first part of be aware of what is happening inside your repository. Even your workflow files might be an attack vector. Let's dive now into the runners that are executing your workflow files. We have two types of runners. We have self-hosted runners where you install everything yourself. And we have Ubuntu latest. In this case, we have a set of GitHub hosted runners that are always have a certain set of labels. In this case, Ubuntu latest is the one that tells us that we're using a specific version from a GitHub hosted runner. And they come, of course, with some pros and cons. With a self-hosted runner, you install that on a cloud environment of your own, or a server, or somewhere in your data center. And that means that you host it yourself, you already pay for the compute. That also means that securing that thing is now your responsibility. Any tools that you install in there need to be updated with the latest security updates as well. It's now your responsibility. It does give you the option to have a very specific environment set up. For example, you can say, hey, I need a GPU, and currently the GitHub hosted runners don't provide that. So you set up a server yourself that has that capability. Or install specific software that needs a license on that machine, for example. That is a reason to use a self-hosted runner. It also doesn't come with extra usage limits from GitHub's side. So you don't pay for anything specifically there. There's no limit of how many runners that you can install by default, or how long things can run, for example. Those are just following the basic guidelines of, for example, a job can only run for 6 hours. Doesn't matter where it runs, just to protect yourself and your own environment as well. If you then move over to GitHub hosted runners, now all of that responsibility has shifted over to GitHub. They maintain an operating system, they keep that up to date, and they install tools for you, lots of tools. I think the current container that they use for that is 20 gigabytes large. So lots of tools are already pre-installed, but they decide what to install. That means that they pay for the compute, and they want you to pay for the compute as well. If you have public repositories, then it's fine. You have 3 minutes to go with that. But otherwise, it depends on your plan. So if you have an enterprise plan, you get a fixed set of 3 minutes available each month. And if you go over that set of minutes, then you start paying by the minute that you use, because they host the compute and all the security responsibility for you. It also means that they give you a completely clean execution environment with each and every run. They, of course, host that somewhere in their own cloud and set it up for you and for all of their customers. And they don't, of course, want to leak any data from customer A to customer B, or even between your own runs. So that means they give you a completely cleaned up execution environment for each and every run. Yeah, the cake monster. I see a question in chat. I'll do that after this session, but I've got some information there as well. Going back to the workflow runners, as I said, if you install them yourself, you need to be very aware of the security aspects of using them. You need to check the environment scope that the runner has access to. If you install it in your own machine, it might have network credentials attached to it because you want to traverse the network and do something with your database, for example, stored somewhere else. That all of a sudden becomes in the scope of what the runner can do. You might want to share state between runs because you have a caching mechanism that saves you a lot of time downloading each and every the whole internet each and every run, and that might seem beneficial. But be very aware what is happening there. The runner and thus the actions that are being executed on them might have way too much access into your network. So limit, scope it down of what that user can do. Preferably, it should only be able to write in the directory that it is installed on and not be able to traverse your network, for example. Got some examples of why you shouldn't do that later on. As a best practice, you can then say, I want to cordon off even more of the environment that this specific action or runner can do. And you can do that by executing it inside of a container. In this case, I've got a job here that has a step, and the entire step has been wrapped around in a container. So it will execute a container, download the results, and then it will be done. So this is another way of limiting the blast radius of what that action or the workflow file can do. You can also do that at the entire job level, where you say all the steps in this job will run inside of this container image. This, of course, also saves me from installing the OpenJDK onto all of my runners. The runner will download this container image, it will execute it, and all the steps will execute inside of that container image as well. So that's very helpful as well. And it limits, again, what are the things that the actions that are executing can do, because they're always executing within that container boundary. Another best practice that you need to know, especially if you have self-hosted runners, never ever, doesn't matter what you want to do, never run them on public repositories, because that is a huge attack vector. For example, you have your own repository, it is marked as public, and that means that anybody can create a new fork from it. They can add some code in there, that they can read even what your code is doing, they can go through the action logs, they can see what is in there, so they can try to figure out an attack vector, inject that, they might even change your workflow file, for example. Then they send in a pull request, and that pull request could be configured to just execute your workflow file on your self-hosted runner behind your company's firewall or a networking setup. That's, of course, massively scary. You're now running arbitrary code changes from the internet that we all know that we cannot trust on your own setup. So it's very dangerous to do that. So as best practice, never do that. Let that run on a GitHub hosted runner, for example. And then we have ways to mitigate things that you can say, hey, we have verified that there's nothing scary happening in here, and then label it somehow, triggering another workflow that then can run on a self-hosted runner. But by default, never use that. If you want to know some mitigation information for that, let me know. Because what are we, for example, looking at? Well, one of the attack vectors is persisting data between runs. And I already mentioned it. You could say we use a cache, depending on the package manager that you have. You can set up npm or NuGet, for example, to use a global cache on the machine. And that might sound beneficial, but the hard part is that the first one could download those dependencies, build your code, and somewhere either in your own code, in the third-party packages that you use, or for example, the workflow file itself or the action, somehow you override the dependency cache with a malicious version. What happens then? Well, the second run runs. It asks for, hey, do you have dependencies for me? The dependency layer says, of course, I've got some cached here. That makes it easy for us. Here you go. And now we have a malicious dependency stored inside of or built out of artifact. And we roll that out into production. That's very scary, of course. And you might say, well, Rob, that sounds a little bit far-fetched. This isn't happening. Well, this is exactly what happened with the solo window tag last December. I can recommend going to this link, and you get the links through the slide share later on as well. So read that at your own leisure. But it's very interesting to see what happened here. And this is exactly the example that happened. They somehow overrode the dependency cache, injected those malicious assemblies into the build artifact, and then rolled out that build artifact to 3,000 customers who were all now running with that malicious dependency inside of it. And it took months to figure out what has happened and why and when. Well, the attack vector was their pipeline. So persisting data between runs is very scary as well. As a best practice, we then say never share your runners. From the old days, you might say, hey, we have a beefy machine, let's install 10 runners on the same machine. So we can reuse things and reuse that dependency cache, for example, or our own container image layer stores everything inside of that machine as well. Well, we have seen the risk of persisting unwanted data between different runs. And hopefully it's just something benevolent, like they install a Bitcoin miner that you can at least trace and figure out what is happening. But they might try to escape and run a sandbox to reverse the entire network and start encrypting anything that they have access to. And we all know that those attacks are happening each and every day. Also think of all the information that the runner has access to. Private SSH keys stored on that machine, API access tokens that are in there. There are certificates that you store. It's very scary to think of what that thing has access to. So limit the blast radius, install it as little scoped as you can. And as best practice, don't share those runners. If you have the need to set up your own runners locally, then have a process that removes them after each run and then reinstalls them, for example. Clean everything up as much as you can. If you do that by hosting your own runners, it's your responsibility to do that. If you use GitHub hosted runners, they already do that for you. Right, that's already the part for the runners themselves. Let's dive into the actions, because that is what we were here for, the actions themselves. But we, of course, now know that we have multiple attack vectors outside of just the actions. For the actions, I already said you can use them, create them yourself and publish them to the marketplace, or you can go to the marketplace and search for things. Got an example here where we're targeting Amazon AKS. And the nice thing is that the marketplace says, hey, use the latest version, gives you a nice pop-up and it says, copy and paste this code over. If you use the editor for the workflow files, you find that there as well. And then you're good to go. Well, the nice thing is that that users part contains the direct URL that you can copy and paste behind github.com. And then you can go to the public repository. If you want to publish an action on the marketplace, it has to be in a public repository so people can see what is happening inside of that action. Because, I think I already mentioned it, we are running arbitrary code from the internet. The workflow runner just asks the GitHub server for work. Hey, do you have work for me to do? And then somebody triggers a workflow file. And the answer will then be, yeah, sure, here's a workflow file. Download all the actions that are in there and start executing them. And that is what the runner does. It downloads the entire repository and starts doing things there. It doesn't just download the action itself. It downloads the entire repository and then initiates the startup sequence for that. So that means you are running arbitrary code from the internet. So you need to be very aware of what those things are doing. Well, what can you do to protect yourself against harm? There's always a manual step. If you're taking anything away from this session, is please look and verify what the action is doing. Currently, we don't have any reputation level or something that you can say, hey, people are using this action, so this one is safe. It's all open source. And so that means that the responsibility of figuring out if it is safe to use comes up to you, and you need to verify what the action in the repository is doing. Go through the code, go through its startup point, for example. Is it starting up a container? Is it starting up TypeScript? Is it doing other things? Go through the entire repository and figure out if you want to take the risk of using that action in your workflow file. You also need to check all the container images, all the layers that are in there, all the dependencies that it uses, because there's no way to see that from the outside of a public repository. And as I said, the workflow runner just blindly downloads it and starts executing. What else can you do? As I said, that user statement already contains the direct link to the public repository. And it has to be a public repository, and it has to have a properly set up action.yaml file in the root of the repository. And as soon as that happens, anybody can use that action. It doesn't even have to be published to the marketplace. As long as it's a public repository, the workflow file can download it, and then you are good to go. Well, of course, this is an example of a totally non-harmful must-have action. This is the best thing since sliced bread. It only wants access to a specific secret value. Well, guess where I got the example of adding a space after each character in a secret. This is an example of an action that hasn't been published on the marketplace, but everybody can use it, and now all of a sudden they spool out their secrets into the logs. So as long as it's a public repository, people can use it, and there's no real way to see what is happening in there. Yeah, I see this question, Steve. That's exactly where I'm going for next. So we'll get back to that. What can you do to protect? Well, I already said you could say I only want to use actions listed in the marketplace. Well, currently there's no real verification process. Anybody can create a public repository and publish it to the action, and it will be available within seconds. There's also no way to see that an action has been pulled off the marketplace, for example. As long as the public repository is there, you can use it, and your workflow file will not care. It will just execute it. So even though there is a nice bar on top of the repository. When you go to it, well, of course, this might change. And all of a sudden it is gone. There's no way to really see what is happening there. So what more can we do? You can say, hey, there's a verified creator badge on the actions themselves, and maybe I can trust that. Well, it took me months to figure out what it actually meant to be a verified creator. Even going to that link doesn't really tell you anything what a verified creator it is. It only says that the author is a partner of GitHub that GitHub has worked closely with, and it doesn't state anything else. So that's not good enough in my opinion. After a couple of months, I finally found in the publisher documentation a verification process described. And it says you need to have a GitHub profile that is complete. By default, I think you can create a GitHub account with only just a username and a password. I don't think you even need to set up an email address. So they want to know that they have a way to reach you. You need to set it up on the organization level. So you cannot use a personal account for that to become a verified creator. And the organization level then has to have two-factor authentication set up. And they also want to do domain verification through a text record. If you want to know more about the process, go to that tiny URL. It tells you not that much more than this is here, but it is still interesting to read through. And these aspects, of course, are, in my opinion, not good enough. I can create a GitHub profile with an email address that I can read. I can set up two-factor authentication on a new organization that I create. I can probably get a domain that I can verify with a text record. So if this is the verified creator process, it doesn't really add that much value. I'm trying to go through this now, and as I have set everything up, and currently I haven't heard anything back. So I'm still not convinced that this is a good measure to take that say, hey, I only want to trust actions from verified creators. What more can you do? You might say, well, okay, I'm now so scared. I never want to use actions anywhere and just disable it flatly on your organization. Well, of course, we are all DevOps people. And we like to use these things to make our lives easier. We want to automate things. And the bottom ones are very interesting. You could say, I only want to allow local actions within that specific organization, or allow select actions. And those are then a allow list of actions that you want to accept. You have the option then to say, I only want to allow actions created by GitHub. And I'm a bit on the fence by that. I trust GitHub has a better security posture than me as a user has, but then again, it's still arbitrary code. I know the workflow just downloads the entire repository and goes through them. So I'm not that very happy with that, to be honest. Now, for the allow marketplace actions only by verified creators, well, I already mentioned that I don't have insights into the verification process. So in my opinion, that's also not good enough. So the best option is to only allow specific actions. This is an allow list, and you can go nuts inside of this. You can say, I want to use that specific action with that specific version. I want to allow only that specific commit for that action. Or say, in this case, this is my user handle -actions. So this is my actions org that I control. I only want to allow actions from my actions organization. And if then somebody creates a workflow file that doesn't abide by these rules and they trigger it somehow, they get a nice error message that says, hey, you're not matching the allow list. Go talk to a maintainer or an owner for either the repository or the organization level and improve what you're doing here, or get this action allow listed, of course. What more can you do? Well, luckily this is now the default. In the beginning of this year, this wasn't even necessary. You could just say use this specific action and then you were good to go. But now you need to use version pinning. And that says that you say add version 1. And now all the updates for version 1 will be acceptable for this workflow file. This is using semantic versioning. So if the creator then creates version 101 and you only specify you want to allow version 1 into it, it will download the latest version matching that label. So it would download version 101. The thing is that this is still less secure. Version pinning comes from releasing your action to the marketplace, and that is done by using Git tags. And it's very possible that you create a version, say this is version 1, tag that, push it over to the marketplace, and now you start adding code and you thought, well, I forgot that and I still want to include it in version 1. You can say then I want to release it in 101, but you can also reuse that tag. And then, even though you use version pinning, you're still pulling in code changes that you haven't reviewed. So that's not good enough for me. So start at least here, start with that today. use the commit SHA. The commit SHA is immutable. When somebody changes code in a repository and pushes it, it will have a new commit SHA. It's very hard to get a SHA collision. And even if you enforce that it has to be an action repository, that already specifies the layout of the repository, for example. So it's very, very difficult to get a SHA collision. So using the SHA is at least saying, hey, I have verified what the action is doing. I'm okay with that specific version. And now my workflow file will only download that specific version of the repository that I have reviewed. Even if the maintainer adds code, I will not see those changes. I will always know what I am running at. And I think that was the question from Steve. Yeah, pinning the version. So the version pinning is not good enough. At least start using the commit SHA. Then you know what version of the code you're using. Because what are we trying to protect ourselves from? Some of the attack factors that you need to know of are these three that I'll go through one by one. Let's start with the forks of public repositories. I already mentioned them. And the attack factor sits in your workflow file. You can trigger your workflow file based on somebody pushes code into the repository. That happens then on a fork on their end, so that's still straightforward. And you can say when somebody creates a pull request, then this workflow will be triggered. And these two are relatively safe. They run on the merge commit, and it will always have read-only access. Luckily, GitHub has added that later on because the default was the pull request target. The pull request target has specifically been added the underscore target with it. It runs on the target and it has read and write access. That means that it can even access the secrets in there. So if you use this one as a trigger event for your workflow file, this will run on your end. So if somebody creates a fork, sends in a pull request, it still will run on your target, your end, and it has read and write access by default, and it still can access secrets then. So be very aware of when you use these on public repositories. Yeah, that tiny URL is very interesting to see. Every once in a while, GitHub has capture the flag events. They have a security department, of course. And it's a very interesting read of an example where they have the capture the flag event, said this is the repository to the community, asked for feedback, please try to break out of our workflow files. And somebody found a vulnerability inside of the workflow file, misused that to get write access to the repository, send in a pull request to fix that vulnerability, automatically approve that pull request as well because he had read access anyway, or maybe it was a she, I'm not sure, and then automatically close the pull request as well, and then send in a notification saying, hey, I have found a vulnerability, I have already fixed it so nobody else can misuse it, and they got the bounty for that capture the flag event for the day. So it's very interesting to see the ways that people try to break out of the workflow files and get elevated rights into your repository. One of the things that is a vehicle for that is the GitHub token. The GitHub token can be used inside of your workflow file to get access to things inside of your repository. And luckily now we have workflow permissions on top of them. You can set this on repository level and state what the GitHub token has access to. Because we as maintainers of workflows, we use this GitHub token to do things inside of the repository. I can create an issue, for example, in the repository. I can do something with a pull request there. I can, by default, have read and write access to anything inside of the repository for all the scopes in there. So this is a very commonly way to use a secret that has access back to only the repository. Otherwise, you would need to use a personal access token, and that personal access token can see anything that the user has access to, so that scope is way too broad. The GitHub token only is available during the execution of your workflow file. So if that one runs for 5 minutes, it only is valid for 5 minutes and afterwards it's revoked. And it gets injected into your workflow. And the actions might do things with them. Your shell scripts might read that GitHub token and try to then write things back into the repository. And by default, that has read and write permissions. So you can scope that down to only have read permissions onto the repository. So be aware when you use the GitHub token that you now have opportunities to scope it down what it can see. On top of that, you can even scope it down on the workflow itself. So if this workflow executes, it will only have read access to the contents, so it cannot write any Git changes back, and it only has write access to the pull request. So this workflow can never ever create an issue, for example, by running with these permission sets. So be aware that when you use the secret.github token, that you can scope it down and limit the blast radius of what might happen if it would be misused in that window that the workflow is being executed. Another attack factor are the common fields that we can use inside of our workflow files. You want to automate something, you want to greet a new maintainer or a new user that comes into your repository, you want to say hi to them, and we use things like the issue title or body. And if you have development background, you know that this is user input and you cannot ever use trust user input. Even the branch name might be misused in an attack to break out of the sandbox and do weird things. An example of that is this workflow part, a step that says, hey, we do something with the issue title. I want to figure out what is happening there. We run a regular expression on top of that. And if we detect something that is weird, we just say, hey, this is a bad issue, and we stop running. This is running on a shell, in this case, a Linux shell, and that means that those double quotes will be interpreted. If I now send in a payload that ends that string, the title will now be A. And all of a sudden that echo test will now be interpreted and will be executed inside of your workflow. So this is a way of breaking that sandbox and getting out of it and doing, in this case, you're now running arbitrary commands into your shell script. A way to remediate against that is to always insert them as environment variables. Those will always be converted to a string that will not, by default, will not be interpreted. And then you can still say, hey, this is Linux, so I always want to make sure that we never interpret what comes from a user. So echo that out with a single quote, and that way that will not be interpreted, of course. If you want to know more, there's lots of interesting ways to use this as an attack vector as well. Go to that URL again and read more on handling untrusted input. All right, and with that, we'll go over to the last part, is following actually best practices. This was always the guidance when they got started with actions. In the beta, they said, step 1, fork the action over, take it under control, and start using it. And somehow along the way, most of the demos don't even mention that anymore. And that's, of course, scary in my opinion. So I'm here trying to educate everybody. Yes, Richard, it is SQL injection all over again, but now for your pipelines. And it was always available in other systems as well, but now it's really in your face available inside of GitHub Actions. So forking actions, it has some pros and some cons, of course. The pros is this is more secure. The moment you fork that action over is the moment you say, hey, this one is okay for me to use. I fork that over to my actions organization. And in my production organization, I say I only want to allow actions from our own actions organization. So that gives you a formal moment where you take on responsibility and you know that there will not be any code changes unless you make that happen. It also gives you a nice way of having a backup. These days we say that the maintainer might decide to join the circus, and all of a sudden they take all of their code with them as well. Might be deleted, might be moved. Moving is certainly less worrisome than it was before. Most of the time when actions move, it will still work, but it will work transparently for you. So you don't see where it is downloading it from, for example. I have moved actions across organizations and then renamed them, and they still work. Without telling you that rename and move has happened. So you want to have that backup, at least if somebody deletes the repository, because all of a sudden your production pipelines might now be dependent on an open source repository being there. As I said, when your workflow executes, it will download that repository, and if it's not there, your pipeline won't break. It has some negative aspects as well, of course. We have more maintenance work. We need to set up an organization. We need to set up the forks there. We need to keep everything up to date. So that might be a little bit of a boundary. And of course, it limits the action of new actions, the usage of new actions, in your organization. And in my opinion, that's a good thing, because instead of just blindly allowing 10,500 actions that might do God knows what in your machine, you now have it under control of what can happen there. Given where we are at time, I'm trying to speed it up a little bit and to make sure that everybody has a short break before the next session. I have a way for you to keep everything up to date. So let's go over that. There are two ways to do that. It starts both with, if there's anything you're taking away from the session, review what the action is doing, because it might do weird things. Let's dive into the first one, use actions with the commit SHA and then dependable. as I said, you can use the commit SHA, start there at least today, update all your workflow files to include them, and then you can add dependable to your workflow files. And that has support for your actions as well. You can say on this schedule, please look into my workflows directory and update anything you see there. If it happens that it sees an update coming in, for example, I have this there in my own demo application. It says, hey, we have found an action in my actions organization even, so I've already updated it there. And we want to update that from 003 to 005. And you get in a files change list that only states that the version number has updated. If the maintainer of that action has published release notes, it will also show that in the conversation tab. And this will not only work with version numbers, but it will also work with commit SHAs. So if you use that, then you can still use dependable to update all the workflow files in case of need. But the thing is, you need to do that for all the repositories each and every time. You can also follow my guidance that says follow, review the action first, fork that action repository over, and then have a way to update your forks. And you still might use dependable after that. You can see here an example where I have my user account -actions. I fork that over from an example in my own account. And you might say, hey, buddy, we see that this one is behind. There's now a one-click button to pull in all those changes. But that, of course, would still mean that you're blindly pulling in changes from the internet without reviewing them. So I don't like that. I've looked around to find better ways, and I couldn't find it. So as a good open source citizen, I, of course, created something because I'm interested in these things. This is the GitHub fork updater. You can go to it, fork it, and it will then keep your forks up to date for you, including itself. It will go on a schedule through your entire organization, go for each and every org, verify if there are incoming changes, and if so, it will create an issue on that repository. You can automatically tag a team, for example, to that, and say, hey, you need to review this one. I give you that compare link, and if you go to the compare link, you can see the actual incoming code changes. And this works for all your forks, so it works for actions as well. And you can see the actual code changes instead of just listing out all the version updates or the release notes, for example. So this is a good way that, hey, I forked it over, made that conscious decision of I want to use that action. And now I move over to actually taking up and owning the maintenance as well and verify the incoming changes. If you then go back to the issue, you can add a label, and only people at maintenance level or higher can add labels. So that's another security measure. Another workflow will run. It will say, hey, we're updating the fork for you now. When it's done, it says we are there, and will automatically close that ticket for you. So it's, in my opinion, a good way to run with these things. So some of the pros of forking, I already mentioned, we have a full backup, but it also gives you full control over all the updates. You're doing that centrally now. And that means that if you have your production organization stating you can only use actions from the actions organization, and we pull in those versions and updates centrally, you might say, I want to skip the SHA lookup in each and every workflow. I want to skip adding dependable to each and every repository where I get, if 5 repositories use the same action, I get 5 new pull requests that I need to review. So that's more maintenance work. And since we're now doing that centrally, you might still want to do that. There's still a reason to use dependable, and there's specific version updates. So if you want to tag it to a version and not have any breaking changes pulled in, that is still a valid reason for that. If you want to know more, go to this blog post of me where I've gathered all the best practices that I've mentioned in here, and I've tried to add more information on top of that as well. All right, and with that, we have come to the end. I've gone over these topics, and the last thing I wanted to do was summarize some of these best practices. So be very aware of the workflow secrets that we've gone over them. If you start thinking of them as public, you start seeing that you need to have a better way of deploying things into your client environment, for example. We have ways for that. Make sure that you look into the actions source code. It is an open source repository, so you can do that. Take up that onus and verify that it is doing the things that you expect it to do. Start now with using commit SHAs. Don't trust incoming pull requests on public repositories. Always be very wary of them, and they are actively being misused, so be aware of what is happening there. Fork the action repository, take over ownership, limit it to those local actions or that actions org. And then, of course, make sure that you still have an organization to test with. You don't want to burden everybody that they cannot do something. I'm currently working on a better process of where somebody can request an action to be added to the internal organization. I can send out a link to that as well. And then I think I'm giving you a great way of keeping your forked updates up to date. So with that, I want to thank you for being here. I'll go through the chat after this one, try to answer all the questions. I'll share the slides anyway, and I'll drop that in the chat as well. So have a nice day for the rest of today. I'm following some sessions myself as well. So happy to be here. If you have any questions, please let me know. I'm always happy to dive into. On the lower left-hand side, you see my Twitter handle, and otherwise go to my blog and ping me there as well. So yeah, thanks.
Rob, there's a couple of questions in the Discord if you wanted to pick up some of the.
Yeah, as long as people are still here, and otherwise I'll type out answers as well. Because I can of course not see them dropping off. Let's see. Code security scanning. Yes, code security scanning with Dependabot and CodeQL, for example. I'm trying to use that on my actions as well. You can do that only on public repositories. So if you fork over actions, you can still set up code security scanning there. But if you want to have it for a private repository, you need to pay for it. So you need to get GitHub Advanced Security, for example. And that depends on where you are using it. So for public repository, it is freely available, and I highly recommend using that. But I can fill another hour with that topic. I'll see if I can get some guidance and add that in the chat as well. Azure DevOps questions and when will it be replaced by GitHub Actions? Thanks for answering that already a bit, Richard. Yeah, Azure DevOps and security posture with GitHub, and I find that one interesting. I really like the Azure DevOps service connections, for example, where an administrator or somebody from some CCOE team that wants to have that control can set up those secrets. And then the people using them in pipelines need to be authorized for that. We have that similarly in GitHub. But the thing is, when they use it inside of a pipeline, it's transparently for them. So you can do the maintenance in a central place which somebody has admin access. You can do that with GitHub as well. But in the end, the Azure service connections in Azure DevOps are still injected into the pipeline as plain text. So it's similarly there. What I really like is the use of OpenID Connect. I'll try to grab a link later on. That's now generally available, I think even. It was announced at GitHub Universe, where you can authorize your GitHub workflow to push into your cloud environment. And you configure that on the cloud environment side. So in Azure, you say if it's coming from this specific workflow, from this specific repository, and that information is available and you cannot change it, then it's okay to use this as a deployment parameter. That's very, very nice to use. So I'll share that later on in the access token. Yes, the Azure DevOps path can be restricted to certain roles, but it still has access to anything that the user that it is linked to has access to. So personal access tokens always have way too much rights. I'm planning to write a blog post on how to handle that inside of GitHub by using a GitHub application, authorize that for a specific repository, and then create a personal access token from that application. So that's very much limiting the scope even more. And that's very interesting use case there. Yeah, I'm continuously reaching out to the GitHub team, pinging them with all the things that I find. It's very interesting to see. I even noted that in some of their documentation internally, they are now referring to my blog post as these are the best practices and we should use them everywhere we can. So at least I'm trying to do my part by educating us as developers in the community. I've been doing this session now for the entire year. So it's always interesting to still see people scare because of all the things that I showed them. So I'm certainly reaching out and I'm very visible for GitHub, bringing back that information. All right, I think that were the questions for now. So thank you so much for the feedback. It feels a lot more interactive than I've seen before. I have no clue what those numbers are in the chat, so that's very interesting. Yeah, I'll go over the rest of the chat later on. I'll add some links here and there as well. So with that, I think we can close it off, Andy.
Okay, we'll close off now and give everyone a break to be able to switch over to your next session.
Yeah.
Thanks.
Thank you for the support, Andy. Have a nice day. Bye, guys.